So this is part of the reading, but I'm going to go over it. Section 2.2 is fractions, but it's just a cursory introduction to them, okay? Chapter 3, the whole chapter is fractions. And you may shrug, you may it just got upset, but the fact of the matter is, if you know fractions, that's the gateway to all proportional reasoning. And likewise, if you don't know them, it's a disaster. So this is just an introduction. So when we divide a quantity into n equal parts, for example, if we divide 6 into 7 equal parts, the size of one part is represented by the number 1 over n, where in this case, it's 1/7. That's the unit fraction. And 6/7 is just 6 of the unit fraction 1/7. In the same way, 6 pennies is just 6 1/pennies. All right? It's just the unit fraction, 1 over a number, right there. Recall from the previous example, we had a class of 24 children. We found the unit fraction, 1/3 of the class, was equal to 24 divided by 3, or you can write it that way, or 8 children. 24 divided by 3 is the same thing as taking 1/3 of 24, and 24 of means multiply. All right, so division and multiplication are closely related. There's one way, and they're closely related. Examples of unit fractions include 1/3, 1/5, 1/8. A fraction is simply a multiple m of a unit fraction and can be represented as m divided by n. In other words, 6/7 up here is just simply 6 of these unit fractions 1/7. Examples of fractions include 2/3, which is 2 of the unit fraction 1/3, or 2 times 1/3, or 3/5, which is 3 of the unit fraction 1/5, or 3 times 1/5. The number on top is called the numerator, and the number on bottom is called the denominator. And the number on bottom is the unit. And the number on top is how many you have of the unit. So here's example 2.5a, which is the first one you're responsible for in terms of make it a PDF file or a Word file or take a picture. So it says find 5 of these unit fractions using addition and multiplication. All right, so if you have 1/4, right? And I'm going to add another 4th and another 4th and another 4th. And one more 4th. So I'm going to have 5 of those 4ths. Now this is because 1/4 can also be written like this, 1/4. So if you add 1/4 plus 1/4, etc., you're going to get 5 of those 4ths. In the same way, if you add 1 egg plus another egg, you're going to get, plus another egg, you'll get 5 eggs if I add 5 of them, right? So that's what's going on here. You don't change the unit. You don't add 1 egg plus 1 egg and get 2 eggs squared or something, right? You just get how many of the unit you have. Now clean that up, and if we want to do it with multiplication, so we got 5/4. Let's put them on a number line here. There's 1/4, 2/4, 3/4, 4/4, and 5/4. So it's more than 1, which should be intuitive to you because 4 over 4 equals 1. And if you want to do with multiplication, we simply say 5 times 1/4. And for those of you that need this, we can put a 1 on the bottom. We multiply the numerators, and then we multiply the denominators. So now let's do 1/6 and take 5 of them. So that's 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6, and I'm going to get 5/6. If I use multiplication, I would go 5 times 1/6. You can do this if you want. You multiply the numerators straight across and the denominators straight across, and you get 5/6. Put that on our number line. We'd be over here at 5/6, because that would be 6/6 would be 1, right? So we're trying to make them equally spaced. There's our 5/6. In the same way, there's our 5/4. So let me clean this up and do tenths. So now we're going to do the unit fraction 1/10, right? And we're going to find 5 of them. There's 1, there's 2, there's 3, there's 4, and there is 5 of them, making 5/10. And I'll write it like this. In the same way, I could take 1 dime plus 1 dime 5 times and get 5 dimes. Now for multiplication, we're just going to go 5 times 1/10, and you multiply the numerators, and that is a rational number, 5/1, and you get 5/10. So let's put that on a number line. It's going to be right here at about 1/2, right? 5/10. There's 1, 2, 3, 4, 5, etc. How can you determine if a fraction is greater than or less than 1? Well, let's see what we know about 1. That was 1, right? Right here, 4/4. Oh, I should have put these tenths down here. Okay. Let me redo that. 1, 2, 3, 4, 5, blah, 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 all the way to 10/10. So here's the number 1. Remember, things that line up vertically in the number line are equal. So 1 whole is equal to 4/4 is equal to 6/6 is equal to 10/10. Get the idea? If I have more than 4/4, like 5/4, I have more than 1. So you could say that if the numerator is larger than the denominator, the fraction is greater than 1. And likewise, if the numerator is smaller than the denominator, like 3/4, the fraction is less than 1. Okay, so we know that 1 hour equals 60 minutes. Now we're going to look at it from a number line perspective, and then we're going to look at it with addition and multiplication, all right? So 60 minutes is the same as 10/10, because that's 1 hour, okay? So I actually should put that up here. 0. It's supposed to be a straight line. 1 hour. So 1 hour is the same as 60 minutes. I'm going to cut 60 minutes into tenths. So how would I find 1/10 of an hour? Well, 1/10 of 60 minutes is the same as 60 divided by 10, which is 6 minutes. So if every tenth is 6 minutes, 1/10 is 6 minutes, 2/10 is 12 minutes, 18, 6 more, 24, or 5 times 6 is 30. 6 times 6 is 36. 7 times 6. 8 times 6. 9 times 6. And finally 10 times 6. So that's one way of doing it. To find 3/10 of an hour, I could have done this. I could have found 3/10 of 60, just like I did up on top when I found 1/10. And I can divide first, because this is the same as 3/10 times 60. And most of you think that, and I'll get to it, that please excuse my dumbass sister means that you multiply first, but it doesn't, because multiplication and division are tied. Multiplication and division and addition and subtraction are tied. It means you can do either one first. So I'm just going to go 60 divided by 10 is 6. 6 times 3 is 18. And that matches what we have here. So if I didn't have a number line, I could do that. Now 2/5 of an hour, we haven't quite got to this yet, but 2/5 is the same as 4/10. So that's just FYI, right? So 4/10 of an hour, that's 4/10 times 60. 60 divided by 10 is 6. 6 times 4 is 24. So 4/10 of an hour right there is 24 minutes. Now I could do this with the unit fraction too. I could say back to 3/10 of an hour. I could say 60 divided by 10 is 6 minutes, and that's 1/10 of an hour. Multiply it by 3, and I get 18 minutes, or 3/10 of an hour. Or take 6 minutes and add it 3 times. So there's a lot of ways of skinning a cat in this one. But an important thing is that multiplication and division are tied, so you can do either one first. Okay, so let's try this thought question. 4/3 of an hour can be thought of as how many minutes? Well, let's find, this is the unit fraction 1/3, but 4 of them, right? There's 4 of those 1/3 right there. Now, 1/3 of an hour would just be 1/3 of 60. Or 60 divided by 3, it's the same thing. So that's 20 minutes. So this would be 20 minutes plus 20 minutes plus 20 minutes plus 20 minutes, or 80 minutes. Now another way to look at it is that 3/3 of an hour is the whole hour, or 60 minutes. And I got 1/3 left. 1/3 of 60 is the same as 60 divided by 3, which is 20. And I can get 80 that way. Might want to watch this a couple times. I usually don't like to add a B, but I did, so you're responsible for this one too here. We're going to find 4/5 of a class of 25 students, mathematically and with number lines. It's basically the same thing. Let's do it, of means multiply. So we're going to find 4/5 of 25. Well, let's find 1/5 of 25. 1/5 of 25 is 1/5 times 25, which is the same thing as 25 divided by 5, which is 5. So if 1/5 is 5, 4/5 is 4 of those, which is 20, right? So, or you can go 25 divided by 5 is 5. 5 times 4 is 20. Got to keep a couple different ways. You want to do it with number lines here, 25. I want to find 1/5. I would divide it by 5. So 2/5 is 10. 3/5 is 15. 4/5 is 20. See how similar the math is to the number lines? So we're going to look at the units on a tape measure, which are sixteenths, eighths, fourths, quarters, halves, and whole numbers, right? And we're going to draw unit lines for each of the units shown on a tape measure. And we're going to represent the fraction 1/8. We're going to find 1/8 of an inch in sixteenths, and the fraction 1/4 in eighths and sixteenths, and the fraction 1/2 in fourths, eighths, and sixteenths. So let's show what I mean here. So here is 1 inch on a tape measure, and it's cut into these different pieces. In eighths, in sixteenths, there would be 1/16, so that's the measurement of 1/16. So there's 2/16, there's 3/16, etc. Eighths, you get 2 tick marks. So there's 1/8, 2/8, 3/8, 4/8, etc. And quarters, you need 4 tick marks. 1/8, 1/16, 2, 4 tick marks is 1/4. 4 more is 1/2. 4 more is 3/4, right there. So when we do that, we get the blue ones here, right? So what this means is that 2/16, 2/16 is the same as 1/8. That's what it means. And the red lines are saying 4/16 is the same thing as 2/8, which is the same thing as 1/4. And this should be cut down a little bit, because 8/16 is the same thing as 4/8, it's the same thing as 2/4, is the same thing as 1/2. They're equivalent. They're the same number. That's just telling you what the blue line, the red line, and the green line represent. So first we're going to fill in this number line. Now there's ways of doing this, and I'm going to choose this way. First of all, I know that these are all 1, right? 1 inch is the same as 16ths, 8/8, so numbers that line up vertically are equivalent. Now I know that 8/16 is half, so I could put 1/2 here. And half of 8 is 4, so I could put 4/8 here. And half of 4 is 2, so I could put 2/4 here. And half of 2 is 1, so I could put 1/2 here. So all these are equivalent. They're the same magnitude, the same length, with different units. From our previous work, we knew that 2/16 is the same as 1/8. So there's 1/8. 4/16 would be 2/8. 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. And it looks like there is 4/8 and 2/4. So there's going to be 2/8 and 1/4. 4/8 and 2/4. That's going to be a 3. And so numbers that line up vertically are equivalent. They're all equivalent. I'm done with halves. These two are equivalent. 1/8 is the same as 2/16. These 3 are equivalent. 1/4 is the same as 2/8 is the same as 4/16. These are all equivalent here. These are equivalent. These are equivalent. And these are equivalent. Meaning they're the same magnitude with different units. So here's the thought question you're responsible for. It says order these from greatest to least. Well, you think about it a minute. Which one is the largest, has the most magnitude, is the largest fraction? Well, this one, 3/4 is less than 1. This one, 3/2 is more than 1. And this one, 11/16 is less than 1. So this one is the greatest fraction. Now, what's the next greatest fraction? Well, if you go back to the number line, you'll see that 3/4 is the same as 12/16. And you only have 11/16 here. So that would make 3/4 bigger. And then 11/16, which would be the smallest fraction up there. And that's one way of doing it. Another way of doing it, if you want to compare 3/4, you could find out how many 16ths they are by multiplying it by essentially 1. And multiply straight across the numerators and straight across the denominators, so you get 12/16. That means 12/16 and 3/4 are the same number with different units. And that's another way of looking at it. So I'm going to do example 2.8a. I'm going to write 1/3 as an equivalent number of 6. I'm doing it creating a number line for 6 1/3. So I need to fill this in. I know that 3/3 is the same as 6/6. So how do I go from 3, what do I do to 3 to get to 1? I'm either going to divide it or multiply it. And the answer is, well, I can divide it by 3, right? 3 divided by 3 is 1. So if I take 6, I need to divide it by 3, I'm going to get 2. So right here is 2/6. So that would give me 1/6 right here. Let me just fill that number line in. So 1/3 is 2/6. You can write it like this, 1/3 is 2/6. So 2/3 right here would be 4/6, right? It's twice as many, twice as many, twice as many. So there's a 3 and a 5. So 2/3 is 4/6. This is just a way of writing it, showing the units, and this is the fractional way of writing it. Thought question. How is it that 1/3, 1/4, divided into 3s gives us 12ths? Well, remember, 12 divided by 5, for example, is the same thing as 1/5. 20 divided by 5 is the same thing as 1/5 times 20. So 1/4 divided by 3 is the same thing as 1/4 divided by 3 is the same thing as 1/4 times 1/3. And we're going to do this in chapter 3. I wouldn't worry about it. It's a thought question. It just extends our thinking. It's like FYI. This is part of your reading, but I just want to touch on it. The multiplicative identity property. It means just this. Any number times 1 is itself. And you know that from whole numbers, right? Or the natural numbers. The counting numbers. What is nice is that now you can take 1/2, for example, and multiply it by 2/2. And we multiply straight across the numerators and straight across the denominators, I get 2/4. So this means, so importantly, that this number and this number are the same. They have the same magnitude. So this is how you can get different fractions that they look different, but they're actually equal, or equivalent, we say. So I'm assuming you read 2.9 and the material before 2.9a. And in this one, I'm going to find three fractions that are equivalent or equal to 3/5 using equivalent form of 1. So I'm going to start out with 3/5. Just pick a form of 1. How about 2/2? You multiply straight across the numerators, straight across the denominators, and I get 6/10. So I can say 3/5 is equal to 6/10. And if I put them on number lines, they would line up vertically. Now I'm going to take 3/5 and keep the numbers low, divide it by 3/3. 3/3 is just another form of 1. Multiply the numerators and denominators, I get 9/15. Put that on a number line, it would line up vertically. 9/15 is equivalent to 6/10 and 3/5. And finally, I'm going to take 3/5, multiply it by 4/4, and I get 12/20. 12/20 is equivalent to all of those other fractions. They're all equal, and that, by number line for that, it would again line up vertically. How many fractions are equal to 3/5? What's your guess? Well, if you guess this, you'd be correct. There's an infinite amount. That's the sign for infinity. Because you can keep going. You can go 3/5 times 5/5, 6/6, 7/7. You could even do things like 3/5 times 2/3 over 2/3. Because any number divided by itself is 1. Show mathematically that 2/5 is equivalent to 10/25. Well, how do you go from 2 to 10? You can only multiply by 5. So if I multiply the top by 5, I must multiply the bottom by 5 to get an equivalent fraction. And indeed, I get 10/25. So I just showed you that these two are equivalent. Okay, so this is one of the most important properties of math, multiplication property of equality. It states if you multiply both sides of an equation by the same number, the sides remain equal. In other words, equality is preserved. So a simple problem like 3 times x equals 21. What we can do is divide both sides by 3, and we get x equals 7. And that is our answer. It's our solution. Now, I just said it's the multiplication property of equality, and I just divide it, right? Well, that is the same thing. Dividing by 3 is the same thing as multiplying by 1/3. I just do this because it's easier. So I'm going to use the multiplication property of equality and solve these two problems. So I'll start out with, don't you like I change colors to keep it lively? 5x equals 37. Now we want to divide by 5 and not by 37, because if I divide by 5, I get 5 divided by 5, which is 1. And 1 times x, just like 1 times 7 is 7. 1 times 8 is 8. 1 times x is x. X is just a number. So if I divide that side by 5, I divide this side by 5, and I can find out what number I need to make the equation true. So in other words, if I take 5x and multiply it by 37/5, I'm going to get 37. How can I do that? Well, how about 5 divided by 5 is 1, and 1 times 37 is 37. So there's proof of that one. This one, it says take this, and there's a times there, right? and solve it for t. In other words, they want it, when it says solve for t, they want the equation to end up as t equals. Okay, so how would I do that? How about dividing both sides by r? What is r divided by r? Well, in any equation, it's the same number. So it's 1. Just another form of 1. So t equals d divided by r. Or time equals distance divided by the rate at which you're traveling. So this is our last example, 211a. We're going to take an improper fraction and we're going to turn it into a mixed number. Improper means that the numerator is greater than or equal to the denominator. So if it's greater than or equal to the denominator, then it's either 1 or something greater than 1. So I'm going to turn it into a mixed number. I'm going to do it this way. I'm going to recognize that if I take 10 away from 13, I get 10 out of 10 plus 3 out of 10. Which is simply 1 and 3/10. So that's one way of doing it when they're small like this. Like this, it's a little bit harder to see, but if you go 41 divided by 5, how close can you get? Well, and the answer would be 8. 8 wholes, and that would use up 40 of the 41s, and I would have 1/5 left. And you can go the other way and say 8 times 5 is 40 plus 1 is 41 over 5. But we're just going this way. And there's 2 examples of how to do that. Now I'm going to solve this and write my answer as a mixed number. Well, if I'm going to solve it, I'm going to divide both sides by 4. Because 4 divided by 4 is 1, and 1 times the number x is x. So I'm going to get x equals 19 over 4. If I divide this, how close can I get? I can get 4. That uses up 16 fourths. Because 16 divided by 4 is 4. So if I use up 16 of them, how many do I have left? And the answer is 3/4. So this is example 211a. We're going to take an improper fraction and we're going to turn it into a mixed number. Improper means that the numerator is greater than or equal to the denominator. So if it's greater than or equal to the denominator, then it's either 1 or something greater than 1. So I'm going to turn it into a mixed number. I'm going to do it this way. I'm going to recognize that if I take 10 away from 13, I get 10 out of 10 plus 3 out of 10. Which is simply 1 and 3/10. So that's one way of doing it when they're small like this. Like this, it's a little bit harder to see, but if you go 41 divided by 5, how close can you get? Well, and the answer would be 8. 8 wholes, and that would use up 40 of the 41s, and I would have 1/5 left. And you can go the other way and say 8 times 5 is 40 plus 1 is 41 over 5. But we're just going this way. And there's 2 examples of how to do that. Now I'm going to solve this and write my answer as a mixed number. Well, if I'm going to solve it, I'm going to divide both sides by 4. Because 4 divided by 4 is 1, and 1 times the number x is x. So I'm going to get x equals 19 over 4. If I divide this, how close can I get? I can get 4. That uses up 16 fourths. Because 16 divided by 4 is 4. So if I use up 16 of them, how many do I have left? And the answer is 3/4. So you're going to take pictures or create a PDF file or even a Word file is fine. And of 85, 86, 87, and 88 and submit them to Canvas. These are the ones I did in the video. 2.5a, 2.6a, 7a, the thought questions, 8a, 9a, 10a, and 11a, and the thought questions. So here's the homework. So use number lines to find 3 of the unit 1/4. So I went over that pretty well. That should be pretty self-explanatory. 2, write multiplication as division and simplify. So 1/4 times 20, as we discussed, is the same as 20 divided by 4, which is 5. That should be pretty simple. So here we're going to find m, in this case, example 3 of the unit fraction 1/4. And there's 2 ways to do it. And those are the 2 ways. We went through that. This one, except for 0 in the denominator, any number divided by itself is 1. Give 5 examples of fractions equivalent to the number 1. Well, how about, for instance, 2 over 2, 3 over 3? I think that you can handle that. 5, I'll go into a little detail here. When you take a natural number n, so just pick one, say 16, and multiply it by a number greater than what? The product, which means the end result, is larger than the original number. And I'll give you an example here. If it's greater than 1, this should be greater than 1, should go right here. O-N-E. And that'll do it for you. You multiply a number by greater than 1, it gets larger, right? Give 2 examples. How about 6 times 2 is 12? 8 times 3 is 24. They're both larger than 1, right? If you take a natural number and multiply it by the number 1, the product is, you should figure that one out. Give 2 examples. Well, I gave, with 3/5, I think, I gave like 4 examples. And if you take a natural number and multiply it by numbers smaller than the number 1, the product is, think about it, I'll let you do that. These should be straightforward to you, right? What do I have to multiply? The only thing I have is 1/2. I'm going to change it into eighths, an equivalency, right? So I'm going to multiply by 1. The trick is, what form of 1? Well, I have a 2 here. What do I have to multiply 2 by to get 8? The answer is 4. So you put a 4 here. You sure as heck better put a 4 here. So the answer would be 4/8. They are equivalent, 1/2 and 4/8. Use greater than, less than, or equal to make the following statements true. It's a good one for you to work on and figure out. These are, it's either true or false on number 8. Think about that. It's a good problem. You can handle it. Match the number with the other number over here that's equivalent. I'll give you an example. 12 divided by 6 is the same as 2. So the line goes from 12 over 6 to 2. And finally, questions 10, that was the multiplication property, right? You're going to divide that by 5. You're going to divide this both sides by 5. You're going to divide both sides by, and you're going to get the answer. And give your answer as a mixed number when appropriate. And we just did mixed numbers. So I think you should handle this. It's not too bad. Anyhow, good luck. And of course, always email me if you have any questions.